going to look at one more case of the law of cosines to help us realize that sometimes, even though we think we have a triangle given three sides, we actually don't have a triangle. So looking at, if I were to sketch this out, I would want to start and say, well, I've got my longest side of 19, so I'm going to call this angle C. My second longest side is 12, so I'm going to call that angle B. And then that can be my 4, so that would be angle A. And like we've done in other examples, I can start to try to figure out what this looks like in terms of the law of cosines. This up, I'm going to start by finding angle C. Now, using the law of cosines, again, that's a squared plus b squared minus 2 times a times b times the cosine of c is equal to c squared. And I'm going to specifically use angle C as angle C here. So that means the 4 and the 12 are going to be our a and our b values. So 4 squared plus 12 squared minus 2 times 4 times 12 times the cosine of c, which I don't know, is equal to the side length of c, 19, being squared. And I'm going to start to solve this. And I'm going to do this in pieces, so I'm going to take these first two together, these next three as a coefficient, and then I can go from there. So 4 squared plus the 12 squared on this left side gives me 160, minus the 2 times 4 times 12, which gives me 96 for the cosine of c. And then on the right side there, the 19 squared, 61. So then if I go ahead and try to solve this, I can subtract off the 160 from that. I get negative 96 times the cosine of c is equal to 201. I can divide off the negative 6, so the cosine of c is equal to 201 over negative 96. And then to finish that off, I could use the inverse cosine and say c is equal to the cosine inverse of 201 divided by negative 96. Now looking at that and what we know about cosine, that doesn't really make sense because cosine is the adjacent hypotenuse. Hypotenuse should always be larger. But even if we miss that, we can try to put the inverse cosine of 201 divided by negative 96, and we end up getting an error in our calculator. It doesn't work. Okay? It's undefined. But that means our triangle doesn't exist, because if I can't find an angle, that means I don't have a triangle. Now, we could have done something wrong with math. We've done everything correctly. But if we look back at our three sides of the triangle, especially the two shorter sides here, if I add the lengths of 4 and 12, that only gives me 16. So really, those aren't going to be long enough to expand past that 19. What this triangle actually looks like is something like this. If I place that 19 on the bottom, I've got a 12 coming up, I've got to be long enough to come back down to be longer than that 19. And 4 is not long enough to do that. I need to add at least 7, if not a little bit more, to eclipse that 19. So 4 and a 12 aren't even going to work. So I could say there is no triangle here for that set of information. Now, I'd much rather just say no triangle based on the side lengths as opposed to going through this entire work. So if I looked at another triangle here, I've got triangle XYZ. Let's say angle X is 10, or side X is 10, side Y is 2, and side Z is 7. Looking at those three sides, I can say that that's not going to be a triangle as well. Because if I combine these two here, that's 9 smaller than 10. So I'm going to get this same situation where I've got a triangle that doesn't quite connect. Because I've got that 7, I've got the 2 here, and I've got the 10 here that's longer than the two of them combined. So I could also say that this is a no triangle case. So the first thing that I want to do, if I'm just given three sides to a triangle, I want to figure out, do the two shorter sides add up to more than the longest side? And if not, like in both of these cases, there's no triangle possible, and there's really no need to do any of this work here. It isn't a triangle because we end up getting an undefined angle, a 0 angle, or a 180-degree angle, all of which don't make sense in terms of an actual triangle.